Welcome back to another session of physics online classes from Riju and PSK, and this is Losov motion, and we are going to discuss about some more common forces in mechanics. So far we studied about tension, normal reaction, spring force and apparent and the real weight. Now we are going to discuss about friction. You have some idea about what friction is. Friction is generally considered as a resistive force which opposes motion. We are going to deal with the detail of friction and check whether it is always a resistive force. Now, I told you before that if there are two bodies in contact, there is a force which is perpendicular to the surface, that is called normal reaction. The contact force has got a component parallel to that surface. The contact force parallel to the surface is called friction. Friction is the component of the contact force parallel to the surface. And what will friction do? Friction always do two things. Friction does two things. Okay. Listen carefully. Assume that there is a body here. Assume that there is a body here. Okay. Assume that this is being pulled by a force F1. Assume that this is pulled by a force F2. Okay. Assume that, so many times assuming, okay, assume that this is not moving. And this is moving. This is called surface, this is called the body. So, body and the surface. Okay. Now, it is not moving. It is not moving. So, there is a force acting on it, but it is not moving means there must be some other force which is cancelling it. Is that okay? Otherwise, this body would have gone. So, you should know that there is a force from somewhere which is opposing and cancelling that one. And this opposing force should be equal to that one. Okay. Suppose if this were absent, this body would have gone to the right. Clear? I will say, if this force were absent, the body B would have gone to the right side with respect to the surface. The body B would have gone to the right side with respect to the surface. Then I will say like this. There is an impending, there is a possible relative motion. Use the word relative motion. There is a possible, I will write like this one, there is a possible relative motion. When is it possible? If this is not there, there is a possibility, but it is not happening because of this force. So, there is a possible relative motion, and this possible relative motion is called impending relative motion. Impending relative motion. And what is the direction of this impending relative motion? B will move to the right with respect to S. To the right side. B has a tendency to move to the right side. That will be easy. Okay. Due to the force applied, B has a tendency to move to the right side, but because of some force, it is not happening. That is why it is not moving. But in this case, there is a force acting. It is moving in this direction. So, there is an actual relative motion. Actual relative motion to the right. Actual relative motion to the right. I will tell you what is the meaning of relative motion. Listen carefully. B is moving to the right with respect to S. B is moving to the right with respect to S. That means, if you look from B to the surface, like you are traveling in a car, you look at the ground, then what happens? The ground will move backward and you are moving forward. So, with respect to the ground, you are moving forward, or with respect to the block, the surface is moving backward. That is what we call as relative motion. Okay. Here again, B is moving to the right. S is not moving, but if you look from B, S will appear to be moving to the left side. That is called the relative motion. So, there is an actual relative motion between them, but there is no actual motion, there is only a tendency of relative motion. Okay. Now, to cut short everything. I have two different cases here, two situations. In the first situation, I will say like this: there is an impending relative motion. Study this word, use it somewhere, impending relative motion. And here there is an actual relative motion, actual relative motion. Imagine you have a heavy truck here, a heavy truck or a bus, you go and push it or you go and pull it, it will not move. Then I will say there is an impending relative motion, which is not there, it is not moving. But you take a small object like a phone and push it like this one, then you can see that the phone is moving to the right. There is an actual relative motion. Fine. The component of contact force parallel to the surface. Here, this is a surface parallel to the surface, which opposes either the impending relative motion or the actual relative motion is called friction. Ho gaya. What is friction? It is the component of contact force parallel to the surface, which will either oppose the impending relative motion or the actual relative motion between two objects is called friction. When is it called impending relative motion? When the body is not moving. When it is called actual relative motion? When the body is moving. This is called friction. Okay, I will tell you the direction of that one. What is the direction? It is opposing. Okay, so B, forget about this thing. Okay, B is trying to move to the right. Trying to move means impending motion. So B will experience a force in the backward direction. This is written as Fs. Now every force comes as a pair. So this force will have a pair which is acting on the surface in the forward direction. Because with respect to the block B, surface is moving to the left relatively, or trying to move to the left relatively, so the force will be in the opposite direction. So this friction will oppose the relative motion. It will oppose the impending relative motion. So on the body it is backward, on the surface it is forward. Is that okay? Right. Now if the body is actually moving, the relative motion of B is to the right side. So the force of friction will be in the backward direction. We write it as Fk. And the floor will experience this force in the forward direction, Fk. And why is it called S here and K here? S for static, not moving. S stands for static and K stands for kinetic. Kinetic means motion. Okay. This is called static friction, this is called kinetic friction. Is that okay? So if there is a motion, the friction is kinetic. If there is no motion, the friction is static. And the friction never opposes motion. Friction never opposes motion. Friction opposes the relative motion or the tendency to move. Now more detail. What is static friction? Definition. It is the parallel contact force that opposes impending relative motion between two bodies. Impending means the possible relative motion, okay, the tendency to move. Its value can be anything between 0 and a certain maximum. Important point. What is the range of, see, static friction has got a range. It can be 0 or it can increase to a maximum. And the maximum value is called limiting friction. Maximum value of static. What is limiting friction? Answer, the maximum value of static friction is called limiting friction. Limiting friction is the maximum static friction. Now, the limiting friction, the magnitude of limiting friction between any two bodies is directly proportional to the normal reaction. It depends on the normal reaction. So we can say it is directly proportional to the normal reaction means we will write like this. We will write the maximum value S for static and I am writing Fs maximum. What is the meaning of Fs maximum? Maximum value of static friction is directly proportional to the normal reaction. Okay, we can write this as an equation. Fs maximum equal to, we write as mu s into n, and how to read this? This should be read as mu, mu. mu s into n. Fs maximum equal to mu s into n, where what is this mu s? This is called coefficient of static friction. It is called coefficient of static friction, and it is the ratio of the same thing. What is mu s from that equation? Mu s is equal to this thing, limiting friction, Fs maximum divided by normal reaction, and this is the ratio of force by force, so this will have no unit. Once more, what is static friction? Answer: the parallel contact force which opposes the impending relative motion is called static friction. Okay. And what is the range of static friction? Answer: it varies from 0 to certain maximum. And what is that maximum value called? That maximum value is called limiting friction. And the limiting friction depends on what factor? It depends on the normal reaction and a constant called mu s. What is the mu s called? Coefficient of static friction. Okay. Now, this coefficient of static friction depends like a coefficient of, I told you it has no unit. Its value can be 0 and 1, 0 to 1, anything between 0 and 1. Okay. This depends on the material and the nature of the surface. It depends on the material and the nature of the surface, whether it is smooth, rough, etc. It does not depend on the area. That's an important point. So, if I say there are two objects rubbing like this, then this coefficient will depend on the material of this one, and the nature, whether it is rough or smooth. But it does not depend on the area. It is independent of the area. Coefficient of static friction. So, you should remember this equation, you should remember these points. What are they? Static friction can vary from 0 to a maximum value, and this maximum value called limiting friction, or it is also written as Fs maximum, and this is given by equation mu into s into n. What is mu s? Coefficient of static friction. What is n? N is the normal reaction. Okay. And the properties of mu is given here. No unit. It can be between 0 and 1. It does not depend on the area, but depends on the nature of the surface and the material used. Okay. See, in normal the pens that we use, the normal pens, the ball pen that we use, okay, this is how your ball pen will look like this, and here you can see there is a rubber cap. Where you hold the pen, there is a rubber cap. Why is there a rubber cap? Next, about kinetic friction. Kinetic means motion. Kinetic friction happens only when the body is actually sliding over other body, sliding or rolling. It is a parallel contact force which opposes the actual relative motion, I told you before. And just like the previous one, kinetic friction has got an equation mu k into n, but kinetic friction does not vary, it has got a constant value. Static friction can vary from 0 to certain maximum value, but kinetic friction is always a constant. Mu k is called the coefficient of, it should be kinetic friction. There is an edit here. Don't copy it exactly as it is, okay. This is, should be kinetic, okay. That must be kinetic. Coefficient of kinetic friction is the ratio of force, again there is another edit here. Both must be kinetic friction. Okay. So, I can write the equation like this one, mu k is equal to Fk by n, the ratio of kinetic friction and normal reaction. Okay. I was doing the copy paste in my slides, that is why the mistake. So, both should be written as kinetic. Fine. In a nutshell, I say friction can be of two types for us now. One is static friction, another is kinetic friction. Static friction happens when the body is not moving. Kinetic friction happens when the body is moving. Static friction can vary from 0 to certain maximum, but the kinetic friction is a constant. Okay. We discussed about the coefficient of static friction and its properties. Here are the properties of coefficient of kinetic friction. Again, it is unitless, no dimension, no unit, and depends on the material nature of the surfaces, as the static friction coefficient is, and it does not depend on the area of the contact. Fine. Now, coefficient of kinetic friction and coefficient of static friction. Okay. What about their magnitudes or their values? You should know that the coefficient of kinetic friction is always less than coefficient of static friction, which means that the limiting friction, the maximum static friction will be always greater than the kinetic friction. The friction which is there when the body is not moving is more than the friction when it is moving. Means, if a body is at rest and you are trying to move it, initially you need to apply a larger force to overcome the high friction, but after it is moving, because mu k is less, the friction will be less. If you still do not understand, consider that there is a body. Assume that you need 10 Newton force to move it. 10 Newton force to move it, that means to start the motion you need 10 Newton, but after that if you want to keep it moving, you may need only 9 Newton. To start you need 10, but to move it, keep it moving, you need only 9, that is the point. Thus we require more force to start the motion than to maintain the motion. This is because mu k is less than mu s, it is a property of coefficient of friction. Okay. Now, what are the different types of kinetic friction? A body can slide on a surface or a body can roll on a surface, sliding as well as rolling. So, kinetic friction is two types, sliding friction as well as rolling friction. Sliding friction happens when the body is sliding over a body. So, opposing force that comes into play when one body is actually sliding over the other surface, because a block is moving on a surface. What about rolling friction? When one body actually rolls, just like a wheel of your bicycle or bike or a sphere or cylinder, then that friction is called rolling friction. You know, it's said that wheel is the greatest invention that humans race have ever done, wheel, because that wheel converts sliding motion into rolling motion. Rolling friction is very, very less compared to sliding friction. That is why motion is easy with a wheel. Rolling friction is very small, very, very small compared to sliding friction. That is why wheel makes motion easy. So, what are the two types of kinetic friction? One is sliding friction, second one is rolling friction. Which is more? Sliding is more. How does a wheel make motion easy? A wheel will convert sliding friction into rolling friction. Rolling friction is very small, motion will become easy. Okay. Now, if you do an experiment, I will tell you what to do. Okay. Consider that there is a surface, a level surface, and consider that there is a body of mass m. You start applying a force F. Initially you will see, initially the value of force was 0, the body will not move. Even after you increase the force, the body will not move. So, there is up to certain period the body will not move, only after that the body will move. I will say like this, if you apply a force F and if you increase it, up to certain value of that force the body will not move, but beyond that the body will suddenly start moving. So, if you plot a graph of applied force here, applied force F here and the frictional force on the y axis, you get a graph like this. And what does it tell you? You can see that from 0, 1, 2, 3, 4, 5, 6, 7 etc. friction is also increasing like this. So, here you can see the graph is a straight line. We can say the frictional force is directly proportional to the applied force. But you can see that up to this force, there is no motion. If there is no motion, this friction is called static friction. So, we can say static friction is directly proportional to the applied force. Okay. And we can say the friction will increase to a maximum value. This is the maximum value of friction. This is what we call as the limiting friction. But once you apply more force than that one, then there is a change in the graph. the friction decreases and then become constant. This is kinetic region. The body started moving. Okay. If these examples, if this explanation is not properly understood, I can give a numerical example. What numerical example? Thing like this, thing like this, thing like this. This is the applied force and this is the friction. Applied force and friction. Applied force is 0, frictional force is 0. So, look at the graph. Applied force 1, friction 1, applied 2, friction 2, applied 3, friction 3. Applied 4, friction 4, applied 5, friction 4.5. I am sorry, friction not 4.5, friction 3.5. What happened? Friction slightly decreased. Applied force 6, friction 3.5, applied force 7, friction 3.5, applied force 8, friction 3.5. Watch this. What happened? Applied force 0, there is no friction. Applied force 0, there is no friction. Applied force increase from 0, 1, 2, 3, 4, etc. Friction also increase 1, 2, 3, 4, etc. So, this region up to 4, there is no motion. There is no motion. It is static. Okay. Now, here at this point here starts motion. Motion starts. And here it is in motion. This is static region, this is kinetic region. So, this friction is static friction. It varies from 0 to a certain maximum. So, 4 is the limiting friction. Then the body starts moving, this friction is constant, this is called kinetic friction. So, I told you in the beginning, static friction can vary from 0 to certain maximum, and the maximum value is called limiting friction, and this is kinetic friction, which is constant. So, to move the body you need 4, but to keep it moving you need only 3.5. To move the body you need 4 Newton in this case. So, that 4 will be marked here, this is your 4 Newton. And this will be like a 3.5. Kinetic friction is 3.5, limiting friction is 4. Okay. So, if you want to move a body, what to do? You need to apply a minimum force of 4 Newton here. The minimum force required is the limiting friction. That is how it varies. So, we can see that here friction increases with applied force. We can say limiting friction is a self-adjusting force. Limiting friction, this one. I am sorry, the static friction is a self-adjusting one. Static friction adjusts 0 to 1 because force increases. When force increases, static friction also increases. So, we will say static friction is a self-adjusting force, but kinetic friction is a constant. Okay. The graph nature is explained here. Pause the video, write down the notes, draw the graph. Now, how do we understand the direction of friction? I can explain that using a diagram here. There is a wall, there is a floor, and there is a block, there is another block, A is on B, and this is tied with a string, and there is a force applied here. Okay. Now, listen. When you try to pull this block B, B will move towards the right with respect to A and the floor. So, this is called the floor. So, we can say B tends to move to right with respect to A and F. So, with respect to A, this is having a rightward motion, with respect to F also it is having a rightward motion. Now, there are two surfaces where B has contact, one surface is here, another surface is here. So, there will be friction on B, there will be friction on B due to floor, due to A. And you can see B is tending to move to the right. So, B is tending to move to the right. So, the relative motion of B is to the right side. So, the friction must be to the left side. So, there will be friction here as well as here. This is due to the floor, this is due to A. So, this is the frictional force on B. from the floor. This is the frictional force on B due to A. So you got the direction because this was being pulled by a force F. What about the body A? Body A has a contact only with the body B. And you see, B moves to the right with respect to A. So A is moving to the left with respect to B. Okay, so I can write here A is relatively moving to left with respect to B, because B is moving right, so A is trying to move to the left. So friction on A should act here. In which direction? In this direction. Friction should act in that direction. And what is that friction called? This is a friction on A due to B. And we should know that FBA and FAB are the equal and opposite pairs. Newton's third law. FBA and FAB will be equal in magnitude. If FBA is 5 Newton, then FAB will also be equal to 5 Newton. There is one more, that is on the floor. There is a floor here. The floor here. The floor is actually not moving, but you can see B is moving to the right and B has got a friction FBF into the left. So the floor will have friction acting here, force of friction on the floor B because of B, and we know that is due to this is the pair of this force, and all these forces are marked here. Okay, we are marking only force on B. We can mark force on A in this direction, and that must be equal to pair of this one, FBA. I think this red color is not a charming color for the board. So this is the frictional force on B. Frictional force on B due to A. A due to it's a printing mistake. You should be careful about that one. This is the force of friction on B due to ground. This is force on B due to A, and this is force on A due to B. Force on A due to B, and there will be force here, force on the floor due to B. All these are the different directions and pairs. Okay. Now, there is advantage and disadvantage of friction. This can be asked in theory examination. What are the different advantages of friction? We can see that walking is possible due to friction. If you want to walk, you need friction. On a slippery surface, you can't walk. Fine. The body sticks together due to friction. See, in my cot here, you can see the button. The button sticks here because of friction of the thread. The fibers of my shirt stay together because of the friction. Without that, bodies cannot stay together. The vehicle, the cycle, bike, everything, the brake works because of friction. Fine. Writing is possible. Writing is possible with friction. Without friction, you can't write. Physically, you can write. Of course, maybe later you can say maybe technology may tell you something about writing. Maybe sometimes without touching also you will be able to write on board. That's a different thing. But physical writing needs friction. Of course, if you want to transfer energy in machineries, you need friction. Like using belt, chain, etc. If you want to transfer energy, you need friction. So these are some of the advantages of friction. Same times, friction has got lot of disadvantages, like friction always opposes relative motion, and this reduces the efficiency. In machineries, this is a big problem. Friction opposes the motion, so you need more energy to run things. Friction causes wear and tear. You are familiar with the wear and tear of your tire, and machinery parts get wear and tear. This produces lot of heat energy. Just simply rub your hand together like this. You can see there is thermal energy produced. This creates a lot of energy losses. This is again a drawback of friction. Okay. Now sometimes we have a wrong idea that friction is opposing motion. So we are going to deal about something like this. Friction is a cause of motion. If something is moving, friction is cause. Like if I want to walk, what will I do? If I want to walk, I will press the floor in this direction. So this is the direction in which I am pressing it. So that will have a component parallel backward and component perpendicular downward. Okay, and we know that the component parallel to the surface is called friction. So I am applying a force in this direction. So the surface will apply a force on my body in the forward direction. If you look into your feet, you are sliding it backward. So your feet is sliding backward. So friction on your body from the ground will act in the forward direction. This is moving your body. This is a popular question. When a person is walking forward, what is the direction of friction on his body? People wrongly say the body is moving to that side, the friction must be backward. That's wrong. When you walk forward, friction is forward because friction is moving your body. Friction is moving your body. Friction is a cause of motion. So this is an important point that you should understand. You are pressing the floor backward and you are getting friction in the forward direction. Without friction, you won't be able to walk. That's why on a slippery surface, you tend to fall because you want to get this friction in the forward direction. Okay. Second point, when you are riding a bicycle, there is a very amusing one. When you ride a bicycle, okay, the friction is moving your bicycle. See the back wheel of your bicycle. The back wheel is connected to the pedal system. You have your pedal and using your foot, you are turning this in this direction. And through friction, that energy will be transmitted to the back wheel and the back wheel will rotate. Back wheel will rotate in this direction and this is the floor, and here the back wheel has a tendency to go backward. So the wheel and the floor, the wheel is relatively going backward because you are forcing it like this. When you force it like this one, this wheel has a tendency to roll like this. So here the wheel is going backward, so frictional force will act in the forward direction. So when you pedal your bicycle, friction on the rear wheel is in the forward direction. That is pushing a cycle in the forward direction. But are you pedaling the front wheel? No, the front wheel is simply moving by its own. So the front wheel when moves in the forward direction, okay, I'll draw the front wheel here. Your front wheel is pushed from behind. If nobody pushes, it will not move. So the back wheel and the mechanism is pushing it in the forward direction. There is a push it is getting. So this point has a tendency to slide forward. This is sliding forward. So friction will act in which direction? Friction at this point will act in the backward direction. So when you pedal a bicycle, friction on the rear wheel is in the forward direction and friction on the front wheel is in the backward direction. Which is moving a bicycle? The friction on the rear wheel is moving you forward. This is actually blocking you. So it's better to have a single wheel. Instead of bicycle, monocycle is always good. But balancing is a problem. But if you are not pedaling and if you are simply riding, what will happen? Both the wheels are moving by their own, so you are not pushing it backward, so friction will act in the backward direction. That is why on a level surface, many times if you don't pedal, your bicycle will stop. Reason? Friction will stop you. But if you pedal, friction will push you forward. So motion in many cases is due to friction. Now listen, there is a truck and there is a box on the truck. The truck is going, box is also going. Who is taking the box? For example, I have a cup here, I have my phone. I am moving the phone. Who is moving the cup? I am moving the phone. Who is moving the cup? Think about the phone and the cup. I have done many experiments with my phone. You can see the result on the screen. Okay. This is the phone. And I am applying a force on the phone and the phone is moving like this one. The cup is here. So the phone is moving to the left with respect to the cup. So the cup has a relative motion to the right side. Are you getting this? The phone is moving to the left with respect to the cup. So, the cup is moving to the right with respect to the phone. So, the impending relative motion, because there is no actual motion between the cup and the phone, impending motion of the cup with respect to the phone is to the right. So, what will happen? Friction, static friction will act in this direction on the cup, and on the phone the same static friction act in the backward direction. F on the cup due to the phone, F on the phone due to the cup. What is moving the cup? The force acting on the cup. So, the static friction from the phone is moving the cup. Same thing, who is moving the block? The block is moved by the friction from the truck. So, if this is B and this is T, then you can say block moves due to friction static on the block by the truck. That is what it is moving. Okay. Now, sometimes we may need to increase friction, sometimes we need to decrease friction. How to decrease friction? By polishing, by lubrication, by proper selection of material, because I told you that mu depends on the nature of the material. Then by streamlining the shape of the body, you can see that the modern cars have got a bullet shape, right? So, that is to reduce the friction from the air. By using ball bearing, because a ball bearing can convert sliding friction into rolling friction. How do we increase friction? That is by making the surface rough, by throwing sand on the rough surface, slippery grounds, and sometimes we use rubber. Like, why do we use rubber for the tire? That is because rubber has got a high friction. That is why we see your laptop, your mixer grinder, everything has got rubber bushes at the bottom, because rubber has got a very, very high friction. If you use the rubber band on your pen and if you rub somewhere, the motion is very difficult, very, very hard. Motion of this will become very hard. So, rubber can increase. By properly selecting material, we can increase friction. So, today's class, all basic theory, all can be asked in theory examination. So, study them by writing the note, refer the textbook, refer NCERT textbook. Okay, we will have to do mathematical side. There is a mathematical side for friction that we will discuss in the next class. Till then, bye, tata.